This is a cool video. We're going to be removing the background of an image just using some math and NumPy and OpenCV. This is video 8 of an OpenCV for Python tutorial series. If you haven't seen any of the others, I have the playlist in the description, and I also have the code for every single video available on my GitHub, link in the description. Without more talking, let's just get into the code. We're going to be working with video, so rather than remiking the wheel, we're going to go to episode 4, video pi, Control A to copy all that, and then paste that in background estimation. Okay, I'm going to go Zen mode here. That's Control K and then Z in Visual Studio. I'm just going to talk through the video code in case you haven't seen video 4, and then we'll start messing with the code to suck the background out of a video. Import CV2, obviously. And here, I was working with a webcam, so I put 0, but now we're going to be working with a file. I have a file in assets, and it's called cyclists.mp4. Is that what it's called? Yeah, cyclists.mp4. So now what's going to happen is CV2 is going to open the file, and that object is going to be called stream. If stream's not opened, let's get out of here. That's a good check to always have. I have a video writer here because we were saving this video before. I'm not going to do that now. We'll do that at the end of the video, but all these values are just things that can help with the video writer. Let's just rename this quick. 8. No background. Okay, then we hop into this infinite while loop and read every frame of the stream. If nothing's returned, we dump out. And we also dump out of this while loop if we press the Q key. Anyway, here we're going to read the resize the frame, write it to an output, and show. I'm going to change this to video. Okay, I'm also going to comment out the resize for now. At the end, let's clean everything up. Okay, recap is over. Let's get into the background estimation. I got to explain what I'm doing first. Let me pull up a whiteboard. Got the whiteboard. Let's say we have a video. Here's one frame. Here's a second frame. And here's a third frame. And there are two things in our video. Thing one, we have a tree. That tree never moves. It's always in the same spot. And also our camera is not moving for this method. So just imagine those are identical trees in the exact same spot. And then we have Joe. Joe was standing next to the tree at the beginning. Then he walked to the middle. And finally, he walked to the upper right-hand corner. He's a little cut off, actually, from the video. If we're looking at this, and we want to look at what is constant and what is not constant, aka what is the background, what is not the background, we know that the tree and the white, that's the background. Joe is the foreground. Joe is not the background. And we want to remove Joe from this image. How do we do that? How we do that is we look at a pixel in all 3 videos. And we look at what the median value is. So in this case, we got white, white, and then blue. The median value is going to be white. And that's going to be the final pixel in that position, which we consider our background. Here we have green, green, green. The median pixel value obviously is going to be green, so that's the final pixel value that'll make it through to the end of our video. And because we're taking median, there can be light differences. So in one case, the green is in shade, the other is in full light. There's going to be some variance in there, and doing the median lets us know that, oh, it's going to be within this green range. That's the intuition behind background estimation in this method, and so I'll show you how to do that now. Rather than looking at every frame of the video, that can get a little computationally expensive, we're just going to look at a random selection of 30 frames. Let's make some Pythonese selection of random 30 frames within our video. Cyclists.mp4. Before I do that, I'm just going to show you the video quick. So if I run this, it should show you the video. Boom. Really quick. Just people going zipping by on the road, on bikes, and also some cars in the background. Okay. let's select 20 random frames from there. First, we're going to select the frame number and then go through and select the actual frame values of those NumPy arrays of pixel values. We need num frames. I don't even know how many frames there are right now. That's going to be stream.get, then the value is cv2.cap prop, I believe frame count. Yep. You also see frame height and width. In this case, frame width is valued at 3, as shown by the 3 here, and frame height is valued at 4. I'm not exactly sure cap prop frame count, what the value is for that, but we just use the constant built into OpenCV. Next, we need 20 random numbers. That's going to be numpy.random.uniform size equals 20. Import numpy also. Import numpy as np. That's going to be a list of 20 random numbers between 0 and 1. You can think about them like percentages. We at 10% or 40%. The frame that's exactly at 421, whatever, I don't know. How do we do that? We're going to multiply that by num frames and final frame IDs equals this whole thing. So we got 20 random frames all sliced in the middle from the first frame, could be the very last frame. I'm not sure, I don't care, but that's our frame IDs. Let's create a list called frames. This is going to be the frames that we'll take the median values from, and they correlate with frame IDs here. For FID in frame IDs, we're going to set the stream pointer. How stream works is it's essentially a pointer. Oh, I'm going to go to this frame, and then it increments the next frame, next frame, next frame. But instead, we're going to make it go all over the place to the specific frame ID. Stream.set cv2.cap prop pos for position, and then frame, I think there's an S at the end. Frames, yeah. And then whatever our frame ID is. So set that little pointer to frame ID in our stream. Just like below, we're going to read in that frame. Copy and paste this. Change the indent. So we're going to read that frame in. If nothing's returned, no more stream. And I'm actually going to do exit here because it's not just no more stream. It's something went wrong. We're literally selecting a frame ID. It should return a frame. And then let's add frame to frames with frames.append frame. So now we have our list of frames. Let's find the median frame. How are we going to find the median frame? Well, it's actually pretty easy. We have median equals mp.median frame, and then we have to specify axis. We're going to do axis equals 0. I'll explain that in a sec. But then convert everything as type numpy.uint8. Just, it makes everything a bit cleaner if we do that. Okay, whiteboard again. What are we doing here? So you can think about t. This is time. And then we also have height and width. T is axis 0. Height and width are axis 1 and 2, and we don't want to calculate the median over this or over this. We want to calculate the median over all of our frames, over t. That's what axis 0 is doing here. Okay, we have this median. I'm just going to show that so we can see what it looks like. cv2.imShow 0, and let's actually comment out everything here. We do not need this just for the time being. Okay, cv2.wait key 0. Oh, what am I doing? imShow median, and the title of the window is median, wait key 0, and then we're going to go all the way down, release the stream, destroy windows when we press a key. I'm going to run that, Control-Shift-9. That does not look right. Oh, I found the error. The problem with using really similar variable names, so I'm doing frame here and then frames. I want us to do the median of frames, not frame. So if I run that, I won't get the gray box anymore. Instead, I will get my road with no bikes or cars on it. Perfect. Let's delete that. And now we're going to uncomment out everything that we had commented before. Step 1, before moving forward, let's convert median into grayscale. So I'm just going to do median equals cv2.cvt color. If you've been following along with the series, you've probably done this before. Median, and then how are we converting it? cv2.color, and we're going from GBR to gray. So now we have median in grayscale. Got our output, blah, blah, blah. Now let's enter into our while true loop and reading everything from the stream. But if you remember, our stream pointer is probably at some random frame right now, so let's reset it. Not in all caps. Stream.set cv2.cap prop. What was it called again? Cap prop pause frames. Position frames to 0. We're going to set that to the beginning. Okay, let's read in the first frame. And we want to remove anything that is not the background. We just want to display a black and white thing. Black if it's the background, white if it's not, so we can make it really clear what's background and what is foreground. Got the basic return frame. If it's nothing, keep moving forward. We're not going to save this video just yet. Okay, so what do we got to do? We got to separate the background from the foreground and look at the differences. First, what we're going to do is diff frame. CV2 has a method called abs diff. CV2.abs diff. I believe that's what it's called. Let's double check. 2 Fs. And what are we doing the abs diff between? We're going to be doing it between frame and median. Since we're doing the absolute difference, it doesn't really matter which goes first, because if it's negative, it's just going to go through the absolute value, get back to positive. We're going to check if that difference is above a certain threshold. If they're sufficiently different, the background and the current frame, then we know that particular pixel is in the foreground and we want to keep it. So threshold and then diff equals cv2.threshold. This is one way to only take the blue pixels from a frame or something like that. Okay, cv2.threshold. What are we thresholding? Frame. Look at the docs here. And our threshold, any, if it's within 30 pixels. Max val, doesn't matter, 255. Oh, whoops. I need to do threshold of diff frame here. That's what we're looking at to see if it passes it. And then finally, what kind of threshold are we doing? cv2.thresh binary. If we're within the threshold, return 1. If we're not, return 0. You can do a different kind of threshold here. I'll show you. Binary, mask, OTSU to 0. Different kinds of thresholds. The binary one is the simplest, so that's what I'm using here. Let's show diff. This is going to go kind of fast, so we're going to do cv2.waitKey20 to add little gaps between each frame. We can still press Q to exit if we'd like, but I'm not going to. Run that. Wait for it to... Oh, it errored out. Oh, we don't convert frame to grayscale. I need to remember to do that. Frame equals cv2.convert color. What are we converting? Frame. And we're going to convert it to grayscale. Let's just copy. I'm just going to type that in. Color GBR to gray. All right, let's run that. Back to Zen mode. And we see, there we go. The camera has some weird exposure at the beginning that doesn't match the background, but everything that white is our cyclists. Their shadows look pretty cool. There's some noise in the tree line, and then also when a jersey passes that has a lot of shadow, it gets matched. Overall, I would say that is pretty good background estimation. Some exposure things at the end also that don't get caught. Let's say we make the threshold super tight, 10, and we run that. What's that going to look like? Very noisy, just because our threshold doesn't matter as much. Overall, less accurate. Let's make that cue to quit. Let's make it a lot more strict, 100, and run that. Much darker, almost no noise, and it's pretty much just the cyclists that get caught, and also the cars, of course, like the things that are actually moving that get caught by our threshold. Cue to quit. Oh, it's not letting me quit. There we go. All right. I want to save this, so I'm going to output.write. Scroll up. What's my file name again? In my video writer, I'm calling this 8nobackground.mp4. Code is in the GitHub, just a reminder. So now when I run this, it's going to be saved. Control-Shift-9 to run it. And we're going to write this to a file. That has been our OpenCV for Python tutorial series. If there's any other tutorials you'd like me to make on OpenCV or any other topic, leave them in the comments below. I try to read the comments as much as possible. If you found this tutorial series helpful, leave it a like, maybe a subscribe, and the bell notification so you see more tutorials in the future. I hope you learned a lot, and of course, happy coding.